We can also use integrals to calculate area. We can use areas to calculate integrals. As we just saw on the previous slide, when you are solving an integral, if it's a geometric shape of some form that we have an area formula for, we can determine what that integral is equal to. Likewise, once we learn how to solve an integral, we've found the way to discover the area under the curve, whether it's geometric or not. So these things kind of go in a little symbiotic circle of life circle, okay? Well, what happens if we have a shape that's below the x-axis? Like, for example, the same problem that we just looked at, except now, instead of being above x-axis, it's below. And that should be a little -2 right there. So apparently I got excited and cut it off. So here we go. We're going to look at this guy now. It's the exact same shape that we had just from the previous problem, except now, instead of being a plus radical 2, radical 4 minus x squared, it's a minus. What does that mean? That means that we're going to open this way. That's a pretty good semicircle right there. So we're going from -2 to 2, and we're going down here to -2. So just like we did on our previous slide, we want to look at the area of the circle, but not the area of the entire circle, just half of that area. And one of the problems now is to find the area under the curve, it's actually going to come out as negative because it's below the x-axis, and everything below the x-axis is actually going to be negative. So one of the things that we're going to have to kind of pay attention to is that area under the curve. So is the sign of the area under the curve. So if it's below the x-axis, what we're going to do is we're just going to put a little negative sign in front of my integral so that I look at it like this, because we want the area to be positive. We want the area to be positive. We can't have negative area. I mean, we can, but right now while we're practicing and learning, this is one of the cool tricks that we can use to find the total area under the curve. Total area is like absolute value, okay? And so here's what we're going to do. We're going to do the same thing we did from just a minute ago. Notice that the distance of the radius is 2. From here to here is 2. So the area between the curve and the x-axis is going to be pi r squared, which is going to be 1/2 times pi times 2 squared, which is 4/2 times pi, which is 2 pi. Okay, so this is our area under the curve. It's units squared. But since we're under the x-axis, it's negative. Okay. However, since we're wanting to know that just total area in general, we would go ahead and look at the absolute value of that. So the area under this curve would actually, it would be 2 pi. Okay. And then if we were to actually look at the circle, the entire circle, well, we would add this area with the area from the previous slide to get the total area that's encompassed inside the circle between the x-axis and the curve itself. Okay. So negative area, there's a couple different ways to look at that. You could have negative area, or if you're just trying to determine like a distance, which distance is almost always positive, you could look at the absolute value of that as well. All right.